Hey, welcome to this Design of Embedded and Intelligent Systems lecture.
Hey everybody.
My name is Baxter, and this is my human Martin.
Hey Dexter.
Martin, what are we going to talk about today?
Good question. First, I'd like to just introduce you to everybody in a little bit more detail. So this is Baxter, one of our robots here at Halmstad University, and you can see that Baxter has two 7-degree of freedom arms and a display and a mobile base and various different actuators.
I got that out. It tickles.
You can also see that he has various sensors, like these sonar sensors around his head, cameras, force sensors in the arms, inertial measurement units, laser in the base.
TAEIS.
So I think robots like this can be really useful both for education and research. So you've just seen an example of an embedded and intelligent system that can do some type of simple interaction. But how can you implement something like this? So here you can see a little bit of the software setup that enabled this. Basically, here I'm running 4 ROS1 nodes, ROS Indigo. In this course, we're using ROS2 currently, but Baxter is using a little bit of an older version of ROS. And these nodes are first a user interface that's running in the top left, a background interaction logic node that's running at the top bottom, and then we've got a node to run speech, playback, and a node to recognize speech. So you can also see the code on the right here for part of this background node that's doing the interaction logic. And you can see that it's very simple to command the robot to move and to speak and to recognize things like when its buttons are pressed. So the software has been set up in a way that it's easy to implement stuff quickly. Have you already guessed what the topic of today's lecture is? Yes, that's right. We're going to start to talk about how to implement this kind of system. After this lecture, you'll also know some stuff like this. Pink-blue separation and Occam's razor. So how can we execute a design in a good way? We should have good work habits, and we should also try to build our skills. Today we focus on the first one, work habits. Do we want to live to work or work to live? So I think burnout is a serious problem for both academics and engineers in general. There was one study that talked about PhD students, how a large percentage of them had some type of mental problem because the PhD studies are so stressful, there's so much pressure. And there's even a word in Japanese for dying of too much work, karoshi. So we want to avoid that, I think. So we start with an anecdote from 1988 from Apple. They decided to break one of their development teams into 2 groups, a short-term group and a long-term group. The short-term group was the blue group, the long-term group, the pink group. And what they found was that over the next few years, the blue team was able to meet its goals, and it grew, even absorbing people from the pink team. Whereas the pink team was in constant trouble, and it was suffering from a second system effect. They were creating systems that were maybe bloated or over-engineered. So what is the takeaway message? That it's very important to divide and conquer. You need to make sure that all of your long-term goals can be reduced into short-term goals. You can try to do stuff like this with work packages and deliverables in your sprints, with Gantt charts and other diagrams. and plans. So every day I tend to write out the tasks that I'm going to work on, and I really like when I accomplish some type of small task, then I can write done beside it. And one of my colleagues told me that he used to always take great pleasure in crossing out stuff when he wrote it down on paper. Breaking is great. You might also have to fix some stuff. So my method for troubleshooting stuff is usually that I look what's going on. If something seems easy, then I just fix it. If it doesn't seem obvious what's the matter, then I list the symptoms that I'm observing. I write it down in actually a notepad or something like that. Then I write out potential causes for symptoms, and finally then possible solutions for causes. Then I go through those one by one. And it's very good when you have a difficult problem to try to be as systematic as you can. Otherwise, you can waste hours on something that could be relatively easy to find a solution to. Documentation, you should have a few common things, I think, when you're writing up your documentation for some product. If there's a license involved, you should mention it. What or where are the main files or parts? How to use this system, if it's code, how to compile, execute, stop it. An example of how to use it. And of course, you don't need comments that don't help. Comments should always be helpful. Research. So some of you who are master students will be starting out in research, and maybe you're not 100% sure about what kind of things that you're supposed to do. For your structure, the introduction usually describes your problem, why it's important and hard, and the basic approach that you're going to use to tackle the problem. The related work section usually comes after, and it's not just sort of listing everything you know or everything that you think has happened within some topic. What you should talk about is really different studies, how they're similar to your study, how they're different. And then at the end, that lets you say what's novel about what you're doing. Method should indicate to somebody else how they can reproduce your research, and you should also have an evaluation. Some students sometimes don't leave any time for this, but it takes time and it's important. Results in discussion, you can talk about what you've done, summarize it, describe limitations and future work. For references, when you're reading papers about some topic, I recommend just first reading the abstract and looking at the figures instead of getting absorbed into low-level details and lots of complicated math formulas. Try to understand the basic idea, and then if it's interesting, go on. Simple can be pretty good in research. So we have these concepts like Occam's razor, that you shouldn't increase the number of entities involved in some idea without need. So in other words, you should try to take the simplest solution when there's multiple solutions available. And KISS, keep it simple, smart person. Basically saying the same thing. Always go step by step, go from simple to more complicated. Things you need to convey in your research, two main things. What is new? So that can be, what did you do exactly? What did other people do? And what was hard? What's the technical challenge that you overcame? Some tools I use for sending heavy files, Dropbox and Box, figures. I use stuff like PowerPoint. Paint.net is a nice free program to do art, and GIMP has a lot of power to be able to use lots of different file types. Movies, Windows Movie Maker and VLC is really ultra useful. Code sharing, I use GitHub to put up my code, and there's a link here if you just want a really simple guide to how you can put up some stuff from Linux. Papers, Word or LaTeX. Animations, I used to use Blender. Vision, OpenCV is really useful, and then there's lots of other cool libraries and tools. Sound, I've used lots of different stuff, some not mentioned in this list, but Baxter uses usually CMU Pocket Sphinx and Festival. Other stuff, just some sort of random strategies. If you're under time constraints, then I think development can be sort of like you're taking a test. You can look at what would be really easy, simple to get out of the way. Going back to what we talked about at the beginning, this the importance of making things tasks easy and that you can finish them in the short term. Also, tasks that are maybe really, really crucial, important tasks. To be happy, some advice. This was Mark Twain apparently who said this, but every morning you can try to eat a frog. That means just do something that you don't really enjoy so much, get it out of the way, and the rest of the day, then you'll be much happier. You can do more fun stuff. So I think freedom is really, really important to leave yourself a range of tasks and to enjoy them as well. If you enjoy something, you tend to be good at it. If you're good at it, it tends to be fun. Backup work regularly. I lost all my data before 2 conferences once, so that really wasn't good. Health is the most important thing, and using your friends and family uh, to relax and enjoy yourself socially. Good enough is important. You don't have to always be perfect about things. For when to listen. In research, you can often look at what other people have done and use something simple that they just use it. Or you can solve problems yourself and maybe you find a better solution that other people haven't considered yet. Both are good. It depends where you want to put the focus of your effort because we only have so much time. Balancing listening and not listening is sort of an interesting concept to me anyway. I think it's very important to be able to understand what people are asking if they're asking a question, what people want, what's the underlying intention. But even smart people can be wrong. So sometimes you should follow what you think is the right way to do it. So here are the answers for today's quiz. Pink-blue separation was about short and long-term goals. Occam's razor is an approach for selecting between multiple hypotheses.
Wow, Martin, that was the best lecture yet.
Really? Thank you.
Yeah, I slept so good.
What?
Your voice is so soothing. I need a few more minutes to sleep.
Okay, well, I guess then we're done for today. Thanks very much for watching. See you next time.